Hello everyone, my name is Javad Tariq, and on behalf of Group 10, we will be presenting our final master thesis on the development of the WeZig building using an open BIM approach. I will start the presentation with the introduction about the project. I will then brief you with our team organization structure and our roles throughout the development of the project. My colleagues will then take over and explain our approach for the initial stages of the project. We will then explain the tactics used during the design stages of the project, in which we will shed some light on the development of our BIM execution plan, design models, and our utilization of the agile methodology for design. We will then go on to explain our approach used during the construction stages of the project, in which we will explain 4D and 5D procedures which were used during the project. Lastly, we will explain the methodology we adopted for a lean handover of the project. So let's dive right into it. Let me begin by introducing the WeZig building. The WeZig building is located in Barcelona, Spain, and is a pilot BIM project consisting of a 10-story high-rise office building with a basement, a roof, and a cantilever at the very first story, shading the entrance. The objective of the pilot project was to implement an open BIM methodology to simulate the complete life cycle of the building from the design stage to the handover stage. Now, utilizing an open BIM approach throughout the project helped the team achieve a vendor-neutral BIM. File exchanges were done using the IFC file format developed by Building Smart. The structural project information model was developed using Tekla structures, whereas the architectural and landscape project information models were developed using Graphisoft ArchiCAD. The MEP project information model was developed using Autodesk Revit. To centralize the common data of the project and facilitate an easy access to the team members, BIMsync was established as a common data environment for the project. After the development of the projects to produce realistic renderings and visualization of the project, Lumion software was utilized. To carry out the quality checks and produce quantity and cost estimations, Solibri tool was utilized. To carry out the visual planning and scheduling of the construction process, Synchro tool was used. Now let me move on to introduce Group 10 to you. We are a group of multicultural people who have been spread across the continents and are yet united through our diversity and our common vision in achieving the best BIM for the WeZig building. Our mentor and acting owner of the project was Mr. Jesus Perucho, who was located in Spain. Moving on, Ahmed Stiffy, located in Germany, took on the role of a BIM manager. Samir Arous, located in USA, took on the role of BIM coordinator. Javad Tariq, located in UAE, took on the role of MEP manager. Jose Alberto, located in Germany, took on the role of structure manager. Nader Ramadan, located also in UAE, took on the role of an architect manager. Lastly, Subendu Patnaik, located in India, took on the role of the handover manager. And that is Group 10. Each assigned role was unique and came with its own set of responsibilities. The BIM manager and BIM coordinator were assigned as a link to the client and to lead the team and look after overall model quality. They were also responsible for the project information management. The architectural, MEP, and structural managers were responsible to produce the package for their respective disciplines of the project. The handover manager was responsible to provide a seamless handover to the client along with the asset information management package. That's all from my side. My colleague Samir will guide you through the next stage of the presentation.
The initial stage was mainly for establishing an open BIM workflow environment so that the delivery teams have clear instruction on how to execute all the project tasks. To do this, we first needed to develop an Exchange Information Requirement Document, EIR. Then from that, we can develop the BIM Execution Plan, the BEP. On the next few slides, I'll be giving you an introduction to the EIR and objectives required by the client, as well as introduce the various communication and coordination platforms we used during the development of this asset. The Exchange Information Requirements EIR was first developed by the BIM manager who took on the dual role of product owner during the initial stage of this project. This document outlines the client's strategic approach for successfully accomplishing all stages of this construction project and covers topics related to management and project deliverables required for this project in a way that is specific, measurable, and realistic. In order to ensure that the client's asset information model, AIM, and related deliverables at the end of the project are of high quality, several objectives were included in the EIR for the appointed party to execute. The main objectives were to deliver the project in line with the principles of a BIM Level 2 compliant design and construction project, to set up an integrated and collaborative workflow to ensure a smooth handover to the facility management team for the operation phase of the asset, to improve cooperation between team members and improve design coordination, to reduce build costs, improve cost certainty of building materials, and reduce waste, to ensure a more rapid design development appraisal, including building, floor, and room area calculations and visualizations of spaces, and also to ensure that the handover of an AIM model that can be maintained throughout the life cycle of the building. We use the BIM Basic Information Delivery Manual, IDM, originally developed by Lockett, as the basis of our 3D model coordination. The purpose of this document is to ensure that our model managers will speak the same language when developing each of the models. We mainly focused on adopting sections 3, subsections 3.1 to 3.8, shown here, of the BIM Basic Information Delivery Manual to establish many agreements between the model managers before any coordination can begin. We had to establish a communication workflow early in the initial stage to prepare for the work ahead. An early version of our BEP established a communication and coordination workflow to be followed by all parties involved on the project. The workflow consists of synchronous and asynchronous communication methods. Synchronous methods required us to use Trello and Slack for discussions and issue resolutions, as well as Zoom meetings for collaboration and assigning tasks to different team members. Planoly was useful in maintaining an up-to-date BIM execution plan and information exchange requirement, EIR, document, as well as for establishing concrete project milestones. Our CDE platform, BIMsync, is where we stored our 3D models and 2D documentation and managed model-based issues such as hard and soft clashes. We tried to keep the information shared simple and straightforward to minimize any miscommunication by making sure that the information contains all the context necessary for the receiver to understand what is being communicated. Issues such as cultural language barriers, different time zones would occasionally occur and have led to some miscommunication and time loss. In cases where we face such barriers, we found it best to communicate through written messages by using WhatsApp as an informal synchronous form of communication. After establishing these open BIM workflows in an initial stage, we were ready to move on to the design stage, which Ahmed Staifi will be presenting next.
Thank you, Sam. We come to the design stage. Here I would like to start directly talking about our BIM execution plan, which explains how the information management will be carried out by our delivery team. Our BEP is the response to the exchange information requirement introduced by Sam in the initial stage. As you see, we built our BEP using the BIM management platform Planoly. in a collaborative way and in live editing mode, where we were editing texts, images, and tables. Further, the team collaborated to progress each section of BAP by commenting, sharing, and publishing content. Here we followed the ISO steps: work in progress, shared, and published. As shown, our BAP divided into 4 main sections: forward, project information, management, and technical sections. The 4 main sections are divided into 20 subsections. For example, as you noted, under section 3, management, the 3.2 is about model uses. In design stage, there are 4 use cases for BIM: the design authoring, or develop the 3D models, the 3D color coordination, clash detection, and visualization. It is worth it to mention that our BAP was a living document, and we worked on updating it at every stage. As agreed from the beginning, we didn't follow any of the traditional forms of project delivery. We developed and delivered the WITSEC building following the integrated project delivery approach to achieve your value proposition. With IBD, we were able to deliver to you the project in cost, schedule, and quality. Our team understood the integration term in IBD as integrating project information using BIM, integrating project team using Agile and Lean management. Agile management was more suitable for the design stage, where Lean management was used for the construction stage. IBD motivated the team to collaborate, and Agile and Lean provide the means to achieve this collaboration. Lean construction focuses on reducing waste, and Agile focuses on being adaptive, responsive, and flexible to change. In the design stage, we use the Scrum process as a tool to implement Agile thinking, where we define milestones, create a plan of actions to achieve project goals in an iterative and incremental approach. This was done by creating a project roadmap, user story map, planning sprints, and define sprint backlog. In this slide, you see our Scrum process and our Scrum team. The most benefit of the Scrum process is that it ensures project information flows. The conversation of the daily Scrum was simple but powerful, with the 3 standard questions. What did you do yesterday to advance the design process? What are you doing today? And what stands in your way? To manage our Scrum process, we use the Trello platform to plan, manage, assign, and track tasks. Trello is quite suitable and offers different separated boards for different purposes. Of course, communication is the key to the success of any project delivery, so we use Slack to create a communication channels organized by topics. Moreover, to link the 2 concepts, communication and transparency, we connected Trello with Slack to have a live update about any change and to keep progress tracked. This strategy combines collaboration and communication, and it enhances the productivity of our team. Nader will continue with you the design stage and go deeper into technical details. Nader, the floor is yours.
3D visualization, which we used for our project for 2 main purposes: visual clash detection and multidiscipline coordination, and visual presentation. For visual clash detection, we used BIMsync for many reasons. Firstly, it's an open BIM platform, which is accepting IFC and generating BCF files and reports, which in turn allows participating in coordination process for all stakeholders and disciplines. Secondly, it's a cloud-based platform, which is making the model easier to access and review from any place in the world. Third reason, that it has been developed specially for models review and coordination. Therefore, it is characterized by many specialized features that make it easy to navigate, filterize, make comments, or provide details, and even analyze IFC data embedded in the project to investigate errors and misinformations. On the other hand, we used Lumion for visual presentation, with 3 main reasons makes Lumion practical and effective for such a purpose. Firstly, it uses real-time render technology. which is given the actual rendering result throughout the working process, making it easy to use, reducing time consuming, and providing good results. Secondly, it is designed specifically for architects, therefore all its features oriented to the construction field. Third and last reason, it's one of a few programs that contains a map view service, which bringing the real location view from map providers to your scene, adding more reality and aesthetic. Specifying clearly the level of information needed is very important for clarifying and agreeing design milestones, and each milestone deliverables between all appointed and appointing parties. Therefore, the delivered model's information shall match the BEP information specified in the project scope milestones. Before the project's kickoff meeting, the model's managers agreed and provided the deliverables level of information needed in the BEP scope by specifying which elements shall be provided in each stage, what is the information shall be embedded or attached to each element, the type of the information or element. Throughout the design stage, the model managers developed specific portions of the basic building. Each manager started his work with the concept information model provided by Zigurat and increased the level of information need to a schematic design level. Lean construction strategy aimed to increase the efficiency of the construction process by reducing construction waste and continuously transferring waste into a value. There are 7 types of waste in the construction process to be managed and controlled all through the lean construction process. Correct implementation of the strategy reducing construction costs, which is the main owners and appointing parties concerned, and increasing values. To implement lean construction method in the basic building project, a number of tactics have been followed. First step was the kickoff meeting, where we discussed and determined tactics, activities, roles, one-piece unit, and team agreements. After the kickoff meeting, we published the one-piece unit IFC files to all teams to be used for the quantity takeoff and to produce each team task and time scheduling. Then, we added the task to the track bar, studied quantities and time required for each task using Celebrity tool. Then we started to coordinate the project schedule with all team members by discussing the relation between tasks and the impact of each task on the others. Finally, we added required informations and guidelines for providing process, installation, relocation, and maintenance. Throughout the construction stage, each discipline further developed his portion in the basic building model. Each manager started his work with the design model, which was provided with a schematic level of information, and increased it to the construction level of information, as well as we expanded our authoring tool package by adding Tekla structure.
The so-called fourth dimension was used to visualize the construction process of the entire project. To do this, a schedule was created using Microsoft Project and then imported into Synchro Pro, together with the IFC models. Once the files were uploaded, it was proceeded to assign resources to activities, and by trial and error, several corrections were made either to the models or to the schedule. One important advantage of this process is that the team can visualize, in a sort of real-time perspective, the different processes being carried out at the same time and also in sequence, which comes in handy when coordination between several trades such as concrete, steel, MEP installations, curtain wall systems, and so on is needed in order to avoid clashes between different teams or to avoid waste due to idle time caused by waiting. This process is not only limited to the actual facility. One can easily simulate the movement of the cranes and different equipment. It is also possible to visualize the delivery of materials as well as the removal of construction waste. This is an advantage, for example, for projects which do not have much space and need to maximize the efficiency of the area they have. For the fifth dimension of BIM, Solibri was used to take advantage of its capabilities to work with several models, creating one complete federated model, which is useful, as we will see further, not only for the quantity takeoffs, but also for the quality control of the interaction of the different building components. With Solibri, the process of obtaining the quantities of materials happens smoothly. Manual data mining of the parameters was required to correctly classify all the objects before any quantities could be accurately extracted. After the element classifications were done and the quantity takeoffs were obtained, they were exported in the form of Excel reports so that the development of cost estimations could be carried out. With these reports, approximate prices were assigned to give an estimation of the costs of materials. As mentioned before, Solibri helps the quality control process. Thanks to its visualization tools and that it is possible to load many models regardless of the size, it's possible to do individual walkthroughs inside the federated model and spot check the small details that may be overlooked by looking at the complete model from the outside or the different level drawings. When team walkthroughs were necessary, BIMsync was used as the main tool because of its accessibility and that it is a cloud-based system. The team had a small issue when using BIMsync. It could not render fast enough the models, which were of considerable size. But a way around this problem was found by connecting both Solibri and BIMsync in order to share the issues found in each one. The team also had several benefits for the most important part of the quality control, the clash detection. All the hard clashes were obtained, analyzed, and closed using both Solibri and BIMsync. 3 different clashes were performed: architectural versus structural versus MEP, and structural versus MEP. Each one of the clashes was analyzed and assigned to the corresponding manager for correction in the native model. Now, my teammate Subhendu will talk about the handover phase.
Hi, I am Subhendu Patnaik. I am going to brief the processes we followed for a smooth handover of WYSIG building project as per the requirement of the EIR and AIM. Post that, I will share the lessons we learned from this project on which our group is working together since last around 10 months. Now the final handover IFC models are ready and we populated the COBI data on BIM and scan site. We used the architectural and MEP model. The populated COBI data were validated from the available design drawings. This information is going to help the client in its asset management and smooth operation and facility management. We advise the client to update the COBI data periodically to capture the assets, if any, to be retrofitted in the facility in years to come. Master Information Delivery Sheet was also prepared as per the requirement of BEP. It basically contained informations on list of documents prepared, its naming, number, version, convention, specifying formats, etc. We have been constantly updating our master information sheet at a regular interval on the designing and construction phase. Both the COBI and master information delivery data were prepared on MS Excel format. Lessons learned from this project is quite vast. However, in short, we learned much on interoperability, agile management, and lean construction methodologies were key to our success on this project. Building Smart has truly broadened the horizons of spearheading this revolutionary step into open source file formats. Thanks to the IFC format, it was possible to work in several countries with different time zones and with a variety of tools with minimum issues. For Group 10, the greatest value that was obtained was the improvement in communication of issues. Due to the easiness and convenience of BIMsync, issues were rapidly detected and communicated. The project was an excellent example of how the BIM methodology can improve all phases of a project lifecycle. In future, BIM methodology will be standard uses for all construction projects, which will certainly improve the amount and quality of BIM and open BIM tools. At last, on behalf of our group, I thank our alma maters and Zigurat Global Institute of Technology at large to mentor us and brighten our knowledge on BIM management through this course. Thank you all.
you.